All right, today we're tackling something called the Cheetah Framework. Sounds pretty cool, right? Fast, powerful, maybe a little mysterious. So what is it really? Let's jump in and find out.
So, that's the big question, isn't it? What exactly is Cheetah? And this is where it gets interesting, because when you start looking into it, you run into a bit of an identity crisis. So, check this out. On one hand, you've got something called a modified Cheetah optimization controller for electronics. But then, you also have a computational code for energetic materials. Whoa. Are these two things even related? Let's start by digging into that first one. Okay, first up, Cheetah the Optimizer. This one is all about getting incredibly precise, almost perfect control inside electronic systems. So the core of this thing is what they call Modified Cheetah Optimization, or MCO. You can basically think of it as this incredibly smart algorithm, and it has one single job: to send the exact right signal at the exact right time to these electronic parts called converters. It's all about total, flawless control. And how does it do that? Well, it uses a proportional integral controller, or PI controller. Now, that sounds complicated, but the analogy is perfect. It's like a hyper-intelligent cruise control for your car. But instead of just managing speed, it's managing the flow of power in complex electronics. And it's reacting instantly, constantly making these tiny, perfect adjustments. And this is how it all works. In a flash, it's this super fast loop. First, it senses that something needs to change. Then, the algorithm instantly calculates the perfect fix. And finally, it acts, sending out that precise signal. Sense, calculate, act. It happens so fast you'd never even know it.
Okay, so that's the optimizer. Now we're going to completely switch gears and meet the other Cheetah, the simulator. And trust me, this is a whole different beast. This one is all about predicting the future.
Right, so this Cheetah, it's not a physical controller. It's a piece of software, a seriously advanced computer program. And its whole purpose is to run these incredibly complicated simulations, basically to figure out what's going to happen when you mix different chemicals together. It's a predictive powerhouse.
So what can it predict? Well, think of it like a crystal ball for chemistry. It can tell you what the final stable state of a chemical mixture will be, which specific molecules are going to form, how much heat and energy will be released. It's basically a virtual chemistry lab for reactions that are way too complex to just guess at.
But here's the kicker. This Cheetah code isn't just for any old chemistry. It's specialty: energetic materials.
And what does that mean? Well, the source material specifically mentions complex solid propellant systems. Let's just call it what it is: rocket fuel. Yeah. This code is used to safely predict the incredible power of some of the most potent materials on Earth.
So here we are. We've got two incredibly powerful but very different tools, and they're both named Cheetah. One is controlling electronics, the other is simulating explosive power. It's time to finally solve this identity crisis.
So let's put it on the table one last time. Are they the same thing?
And the answer is a big, clear no. They are totally separate tools, built for completely different jobs in totally different fields. The mystery's solved. It's just a shared name, not a shared system. But, and this is the really cool part, even though they're different, they kind of share the same soul. The optimizer is all about real-time precision for electronics. The simulator is about predictive precision for chemistry. See the theme? One acts, the other predicts, but both are chasing that exact same goal: the perfect, calculated result.
And that's why the name Cheetah is so perfect for both of them. They really do share the spirit of the animal they're named after. They're both inspired by its incredible speed, they're both engineered for absolute precision, and they're both driven by really complex computation.
So that leaves us with a question to chew on. The Cheetah inspired two amazing but totally different pieces of tech. It makes you wonder, right? What other natural wonders out there are inspiring the technology we'll be using tomorrow? Thanks for joining me on this one.